what if the right-hand side of our ODE is non-zero? In this case, we get what's called an inhomogeneous equation. So in particular, let's try to solve y double prime minus 5y prime plus 6y equals 6e to the 4t. And what I'll tell you now is some skeleton, and then soon we can fill out the details. So the first step is to find what's called the homogeneous solution. In other words, let's solve the equation where the right-hand side is 0, because we know how to do that. So solve y double prime minus 5y prime plus 6y equals 0. Again, remember the roots of the auxiliary equation are 2 and 3. In this case, we get y of t equals ae to the 2t plus be to the 3t. But to specify that it's a homogeneous solution and not the original solution, we write a little circle. So y0 is ae to the 2t plus be to the 3t. The next step is to find what's called a particular solution. Particular solution. Meaning, find one solution of the original equation. Find one solution of the original equation, y double prime minus 5y prime plus 6y equals 6e to the 4t. I will show you how to do this in the next video. We will need undetermined coefficients. So see next video. And it turns out the result will be y of t is 3e to the 4t. So one solution will be 3e to the 4t. And to specify that it's one solution, we write a little yp, as in particular solution. And now the question is, what is the general solution of our equation? So general solution. Okay, in other words, what's the answer to the question? It turns out all you need to do is to add both solutions together. So fact, the general solution to y double prime minus 5y prime plus 6y equals 6e to the 4t is simply y is the homogeneous solution plus the particular solution. So here the answer is y of t equals ae to the 2t plus be to the 3t plus 3e to the 4t. Which is quite amazing, because what this says is, if you find just one solution to the equation and you have your homogeneous solution, you actually find all the solutions to the equation. Or sometimes this is said that the general solution is just a translate of the homogeneous solution. So if you find a homogeneous solution, you just have to add an extra thing to get the general solution. Now, why does this work? So it's fairly quick proof, I would say. So why this works? So on the one hand, well, we need to check that this is a solution. So on the one hand, we can check that y0 plus yp is a solution. of our equation, y double prime minus 5y prime plus 6y equals 6e to the 4t. This is left as an exercise to the viewer. All you need to do is plug in y0 plus yp into the ODE. Plug in. On the other hand, now suppose y is any solution, to our differential equation, to y double prime minus 5y prime plus 6y equals 6e to the 4t. Define a new function. So we'll call this y0 to be the difference between y and our particular solution. So y minus 3e to the 4t. Careful. I am not claiming yet that y0 is a homogeneous solution. So far, what we did, we took any solution, subtracted the particular solution, and we called this new thing y0. But what you can do, just by plugging in this y0 into the equation, you can check that y0 actually is a homogeneous solution. So then check by plugging in that y0 solves y double prime minus 5y prime plus 6y equals 0, the homogeneous equation. And in particular, we know how to solve y double prime minus 5y prime plus 6y equals 0. This simply implies that y0 is ae to the 2t plus be to the 3t. And then we can use a definition of y0. So y minus 3 e to the 4t is ae to the 2t plus be to the 3t. And in the end, we do get that y, so any solution to our ODE is ae to the 2t plus be to the 3t plus 3e to the 4t. In other words, y is the homogeneous solution plus a particular solution. So this ends the proof. And what is really the takeaway? The takeaway is to solve inhomogeneous equations, you first solve the homogeneous equation. So inhomogeneous equation is homogeneous equation, which we know how to solve, and you find just one solution of the original equation. And the whole point of the next couple of lectures is to figure out how to find the particular solution. So this raises a question, how to find yp. And in this course, we'll discuss two methods. The first one being undetermined coefficients, which is part of the next video.